Hello, scholars. The mole, we've been talking about the mole. You're getting acquainted with the mole. It is the international unit of measurement of matter, especially in chemistry when we think at the atomic level, at that really small level of atoms and ions and molecules and formula units. So we're going to talk a little more about mole and get you better prepared to attack those problems. And back a few years ago, this was at a chemistry meeting, I met this character, Meg a mole, Megamole, a big mole character, fun person, or mole to be around. We had a great time. So the mole is a unit of measurement. It is 6.02 times 10 to the 23rd particles. We use the word particles as a general term, just things, pieces. It could be an ion, it could be a molecule, it could be an atom. There's just a general number, that many of them in 1 mole. 1 mole also equals the molar mass in grams. Okay, I'm going to go a little more through this just for better understanding, because it's not an easy concept to grasp and use to solve problems. So a mole, it could equal that number, very big number, a mole of things, but also can equal a mass in grams. We have this picture, mole being in the middle. Mole can be expressed in grams, and we have to use the molar mass ratio. And we have to calculate that for a given substance, whether it's an element or a compound or an ion or whatever, a chicken. It weighs a certain amount. A mole of that substance weighs a certain amount. Okay? A mole is also going to the right side is a number of particles. 6.02 times 10 to the 23rd. We know that as Avogadro's number, coined after Amadeo Avogadro, a scientist from way back. So we have that picture. Keep that picture in mind. Now, I want to talk a little more about molar mass. Molar mass. I think not everybody has a good enough understanding of what we mean by molar mass. Now, on the bottom there, we see that we have these ratios. A ratio means the top and the bottom have this relationship. So 1 mole is equal to the molar mass. And we could switch those around when we use them in solving problems. These are the ratios. Molar mass, 1 mole. Okay, they're equivalent. And also 1 mole is equivalent to that Avogadro's number. And we could flip that, have it on top or bottom. And we use that in our dimensional analysis, how we solve problems. And we'll have a couple of examples to follow. Molar mass. Molar mass is what's the mass of 1 mole of whatever we're talking about. Okay? Molar mass is the mass of 1 mole of whatever we're talking about. And a mole, remember, is 6.02 times 10 to the 23rd. Now, it's often related to a dozen. A dozen, we know, is 12. Well, do you know that there's 6 sizes of eggs? Yes, 6 types of sizes of eggs. Maybe you know just the general ones. We know there's small, and there's medium, and there's large, and there's jumbo. Well, there's extra large. And then there is micro. So there's 6 different sizes of eggs. They all have a different mass, a mass of a dozen of them. Well, that's similar to all our elements. Our elements on the periodic table, each of them have a different mass. But a mole of them all have 6.02 times 10 to the 23rd, and a mole of any of them are going to weigh different. Okay, for instance, a mole of tungsten, my favorite element, W, signified as symbol is W, well, it has a molar mass of 183.8 grams per mole. Get that right from the periodic table. 183.8 grams per mole. Tungsten, very interesting element. It is the most dense element that we know of, actually. It's the same density as gold. That's a sidebar. Okay, that's 1 mole of tungsten. What about 1 mole of hydrogen? That's the lightest element. Well, is 1 gram per mole. 1.0 gram per mole. We get that from the periodic table. So a mole of hydrogen atoms, that's 6.02 times 10 to the 23rd, weighs 1.0 grams. What about a mole of calcium hydroxide? Okay, we know that's an ionic substance, ionic compound, has the formula unit of Ca, calcium, and OH2. It's a polyatomic. Well, we add up all the masses of each one of those elements in a formula unit, and it is 74.1 grams. So its molar mass is 74.1 grams per mole. And in that mole, like always, in that mole of 74.1 grams, there are 6.02 times 10 to the 23rd formula units of calcium hydroxide. I hope these 3 examples clears that up if you weren't clear on what molar mass is. What about a mole of chickens? Now, a chicken, you may know, is a general name for those things we can imagine, but a chicken doesn't tell the whole story. We'd have to say what kind of chicken you're talking about, a hen or a rooster. But let's take just an average chicken. Average chicken weighs, so how much does that weigh? It's about 7.5 pounds. Okay, now chickens come in all sizes, right? Hens and roosters, big, small. But let's say it's 7.5 grams. 7.5 grams equals 3,405 grams, roughly. Okay, if you do the conversion, because we're talking about metric system units, and that's grams, not pounds. Okay, so 1 mole of chickens, which is that huge number, 6.02 times 10 to the 23rd chickens, each one of them weigh 3,405 grams. Okay, how much does a mole of chicken weigh? That's going to be its molar mass, and it's a huge number. 2 times 2.05 times 10 to the 27th grams per mole. So a mole of chicken weighs 2.05 times 10 to the 27 grams. It's hard for us to imagine that much, but that's a lot of chickens, and each chicken weighs a good amount. A mole of chickens is about 160 times the Earth's weight. Right? It's hard to grasp or imagine that, but that's a mole. A mole is a huge number. But when we talk about mole of tiny things like atoms and molecules and compounds and ions, then that makes it into amounts, because they're so tiny, it makes it into amounts that we can weigh and see. So that's why this mole unit is important in chemistry. A mole of chicken feathers, each happens to weigh a gram. So how much does a mole of chicken feathers weigh? Well, it weighs 6.02 times 10 to the 23rd grams per mole. So think about that. Each chicken feather weighs a gram that's a lot less than a chicken, right? You need about 3,405 feathers to equal one chicken. Anyway, this was about chickens, right? Okay, 25.0 grams of silicon is how many moles of silicon? Okay, so silicon. So we need to convert or go from 25.0 grams to moles. So what we need to do is use molar mass of silicon. Molar mass of silicon from the periodic table is 28.1 grams per mole. Right from the periodic table. We're going to use that, and now we're going to set it up in our dimensional analysis setup. And that's it right there. We put down what we know, 25.0 grams of silicon, and then we use that conversion factor. 1 mole of silicon is 28.1 grams. Right? See how it's set up? And now we can cancel out grams because it's on top and bottom. Now the answer, we just have to multiply the top, divide by the bottom, and we'll come up with how many moles. The mole is the only unit left, and that's the answer. 0.093 moles of silicon. Now, this is the correct way to set up the whole and show your work. So every time you do one of these problems, we need to show all our work, not just write down the final answer. That doesn't show me that you knew how to solve this problem. Okay, so, and then in the end, you have your answer. Okay, that was good work. You want to put it in a box or rectangle, kind of identify, here's what I got to, here's my answer, and here's the unit. In this case, it was moles of what? It's silicon, Si. Okay, so that's the whole setup. A nice example of a one-step conversion problem. We went from grams to moles. Okay, a little more involved question here. A glass of water is about 300 milliliters, and each milliliter of water is equal to a gram, so it's a nice conversion. A milliliter of water is a gram. That's because its density is 1 gram per mil. Okay, so I have there, it's also 300 grams of water. How many atoms of oxygen? Okay, so we want to, in this problem, go from grams to atoms. Now, if you look back earlier, or you have it in your notes somewhere, we're going from grams, we have to go to moles, and then to number of atoms. We're going to use 2 different conversion factors. So first, water, we have the molecular formula of water, H2O, and conversion factors that we need. We need to go from grams to mole to number of atoms. And you could see there the conversion factors. From grams to mole, we're going to use molar mass. We'll get that from periodic table. And Avogadro's number of 6.02 times 10 to the 23rd atoms per mole. And we're going to set this up in the dimensional analysis strategy. Okay, so let's do that now. Glass of water, and the question was how many atoms of oxygen. Okay, so we're going to write down what we know. We know that it's 300 grams of H2O. So we went from our knowledge that water has a formula of H2O. We want to find out how many atoms of oxygen is in that glass of water. From the periodic table, we're going to get the molar mass of H2O. And the molar mass would be 2 hydrogens, each are 1.0 grams per mole, and the oxygen is 16.0. Add those up, and we have the molar mass of water, 18.0 grams per mole. Now we're going to put that on our bridge to solving this problem in the dimensional analysis right there. 1 mole of water, 18.0 grams. We set it up so we can cancel out the units of grams, and we get to moles. So we made the first step. We went from grams to moles. Now we want to go to number of atoms, and that's Avogadro's number. Again, we're going to use this ratio, this equivalency of 1 mole of water, or 1 mole of anything, but we write down 1 mole of water is equal to 6.02 times 10 to the 23rd molecules of water. We set it up so we can cancel out the molecules. So top and bottom, we're going to cancel those out. And now we have the number of molecules of water. Now we have one last step. How many oxygen atoms are there in each molecule of water? Well, that's not very hard, but we do want to show that we went through that thinking process. There's 1 atom of oxygen per 1 molecule of water, and that's what's shown in that last step. Now we can cancel out molecules, and now what we have all the information down there to get to our answer. So we're going to multiply the top numbers, 300 times 1 times 6.02 times 10 to the 23rd times 1, and divide that by what's on the bottom, which is 18.0 times 1 times 1. So the bottom basically is 18.0. Now, we have to be able to put that into the calculator and come up with an answer. So that involves knowing how to put 6.02 times 10 to the 23rd into the calculator. Hopefully you know how to do that. It's very important to be able to put superscripts or to the power into your calculator. If you don't know how to do that, look at some tutorial about how to do that for your calculator, or if you're using your Chromebook's calculator. Okay, so now we solve that, and we come out with this. 1 times 10 to the 25 atoms of oxygen. So after all that, we come up with this answer. I should have put a box around it, because this was a lot of work getting to this answer. And that's the answer. That's a lot of atoms of oxygen in that 1 glass of water. If you needed to write that out in normal form, not in scientific notation, it would be kind of crazy. You'd write it out like this. That's how many atoms of oxygen are in 1 glass of water. So thank goodness for scientific notation. We don't want to write out numbers like that. Okay, so your assignment. How did you do on yesterday's? Again, show all your work on your notebook page, fresh notebook page. When I say notebook page, that means your name, the date, what the topic, what's on this page, and all your work, right? So it doesn't have to be the super needed, but it needs to be clear how you got there, showing all the work getting there, right? Including the cancellations and your answers. Now, I'm going to even give you the answers. Here they are right here. The answers to those 6 questions. I want you to show how you got to these answers, right? And this will tell you if you're missing something. Do you have them lined up right? Did you get the right answer, right? So you can check your answers, but on your page that you'll submit, take a picture of and send it and submit it to this assignment showing how you got here. Okay, so hopefully you'll get to these answers and you think about it, take your time. And I hope you have a good weekend. We have an extra day off. But take your time with this and get this right. It's an important concept. And then we'll use this mold to do some more calculations. Right? Have a good weekend. This time of year, usually under normal conditions, if you're a senior in high school, which you have to look forward to in a couple of years, it's prom time. Maybe you have older brothers or sisters or cousins that might be disappointed this year that it's not a usual kind of year and the prom is not the usual prom. But I remember back my prom. It was a while ago, and you're curious what Dr. Weintraub looked like at his prom. Sure. So I'm in this picture, and so in the exit ticket, I'm gonna ask you something about this picture. Okay, have a good weekend. Work on these problems and submit your answer. And ciao. Bye for now. Have a great Memorial Day weekend.